Welcome to another interesting video on vectors. We'll try to understand what is scalar projection. Here is a test question where you need to add the vectors and then find the scalar projection. I hope you find it interesting. You can always send an email on the address given to learn from me. Let us now enjoy the journey of success and understand the solution of the given question. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll solve a practice test question based on projection of vectors. The question here is, the angle between the vectors A and B is 120 degrees. Magnitude of A is 2 and the magnitude of B is 4. Find the scalar projection of 3A plus 4B on B. I would like you to pause the video, answer the question, and then look into my suggestions. So, we are given two vectors which are A and B. Let us try to sketch this. And the angle between them is 120 degrees. Magnitude of A being 2 and that of B is 4. So, let us say, so this is A for us and this is B for us. So, as given, the magnitude of A is 4, magnitude of A is 2, and that of B, let's say this is vector A, right? So we'll say magnitude of A in this case is 2, and the magnitude of B is 4. And the angle between them is 120 degrees. Right? So that is the situation given to us. We need to find scalar projection of 3A plus 4B on B, right? That's the question. So let us first sketch this and understand the question. So 4 times B will be a vector which is in the direction of B but 4 times in length, right? So let's say this is 4B, okay. And 3 times A, so let's say this is 3A. The angle between them will be 120 degrees, correct? Still. Now, 3A plus 4B, you need to complete this parallelogram to form the sum of these two vectors. Correct? And therefore, we can draw the resultant right like this. So that becomes (3A plus 4B). So now if you look into the equation, once you get 3A plus 4B, you need to find the scalar projection of this on B. So that will be, if you draw a perpendicular here, then we are looking for this length. Is that clear to you? Right? So let me write some numbers here. Let's say O, and this is ON, the scalar projection, right? Let's call this point as A, this point as B, and this is the sum S. So first we'll find the sum of 3A plus 4B, and then we'll find the scalar projection, which is O to N, right? So you need to actually find this angle also and the magnitude of OS. Magnitude of OS can be calculated from the triangle given to you, since we know that this angle is 120, then the angle at B is going to be what? That is going to be 60 degrees, right? Magnitude 3A plus 4B means this side is going to be 3. And 3 times 2, which is 6, right? 3 times A, which is 6. And this length will be 4 times 4, which is 16. Magnitude of 4B. So solve the triangle OBS. Find the length OS. You'll use cosine law, correct? Correct? So that is how you'll find OS. Once you find OS, you can find the scalar projection on B. Correct? So let's solve it. You know now the strategy being involved in this type of equation. Let me draw a smaller diagram here so that I get some working space. So let us say this is 4B for us, right? And this is 3A for us. And as we did, we'll find the sum of these two vectors. The sum of these two vectors being that, so OS. This point we are saying A, this point we are saying B. So now the angle here will be 60 degrees. The side lengths are the magnitude vector A is 2, magnitude of is 4. Therefore, when we are looking at 3A plus 4B, in that case, OS is going to be the result, right? So let's find the magnitude of OS. Magnitude of OS can be calculated using the cosine law. We know the side will be 3 times 2, which is 6, and this side is 4 times 4, which is 16. And so we could write this as 6 square plus 16 square minus 2 times 6 times 16 times cos of 60 degrees square root, correct? So using cosine law, we can find the length O to S. So use the calculator to find this out. So we have 6 square, which is 36, plus 16 square minus 2 times 6 times 16 times cos of 60, 196, and square root of 196 is 14. So we get this value as 14. So the length O to S is 14 for us, correct? Now once you find this length O to S as 14, we can find the angle theta using sine law, correct? So we can say that sine theta over the opposite side of 6 should be equal to sine of 60 over 14, and that will give us sine theta as equal to 6 over 14 times sine 60, and we can find this value, correct? Which is 6 sine of 60 degrees divided by 14 equals to 3 square root 3 over 14. Now, to find the scalar projection, we are interested in this value O2, let us say n. So scalar projection is what? is ON, right? Which is basically equal to 14 cos theta, right? So you can find this answer. Either you find theta first, right? So theta equals to sine inverse of 3 square root 3 over 14. So let's find the angle, finding the inverse. 21.7867. So when you plug in this value here, 14 cos 21.67867, 21.7867, you get what? So we have 14 times cos of this value, it gives you 13, right? So the scalar projection comes out to be 13. You get the idea. So that is how we will actually solve this particular question. Perfect. So here is our final solution, right? So what we did was we have drawn this parallelogram where one of the side is 3a, the other one is 4b, the angle between them being 120 degrees. So the sum was O to S, this was A and this is B. We calculated this using the cosine law, right? So that is the cosine law. To find OS when the angle B will be 60 degrees and the two sides given to us are 6 and 16. Once you find that side to be 14 using cosine law, we can then use sine law to find the angle theta. And this theta was 21.786. And then projection is basically when you is the cosine value of 14, correct? So that becomes the scalar projection. You get the idea. So that is how we can actually solve this particular question. I hope the concept is absolutely clear. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.